Today we are continuing our work with volume. Today we're finding the volume of pyramids and cones, okay, which is a little bit different than what we've done this last week, and I'll show you why. You do have two vocabulary words today, the first one being pyramid, which a pyramid is a polyhedron with a polygon base and triangular sides that all meet at a common vertex. And the next we have a cone, which is a three-dimensional figure with one vertex and one circular base. Now, you guys are all familiar with the way a pyramid looks and the way a cone looks. Okay? Now, there are different types of pyramids. You can have a square pyramid, which means it has a square base. You can have a rectangular pyramid, which has a rectangle base. You can have a triangular pyramid, which has a triangle base. Okay? And all of those, there are different ways to find the volume, kind of. Okay, let's take a look at the next slide. Now, on this, you don't have to copy all these things down because these are basically, the bottom portion is the definitions we just copied down. However, what I'm interested in this slide is the heights. Okay, it's showing you the heights for all of these shapes. Now, be careful because the height is not the side. It's not the slant side, okay? The height runs perpendicular to the base and the top. That's how come you have all of these pictures right here that has the height, if you notice, kind of there. It comes off the base and goes straight up to the tip, okay? That is our height. Now, whenever you are finding your volume for these guys, you need to make sure that you use that height, not the side. Okay, don't use the slant height because that's going to give you the wrong answer. Okay? They won't be. I mean, I say that they won't be. It is possible to run into a problem where somebody has labeled them that way, but in the real world, it's impossible to have a slant that's the same size as the height because the slant it has to be longer to get down to the same ground level. Otherwise, it wouldn't touch the ground if it wasn't longer than the height. All right, so let's take a look at our next one. This next slide has our formulas on there that I'm interested in. Okay, this is our formula for finding the volume of a pyramid and a cone. It's 1/3 big BH. Okay, now what is the big B? What's the big B? Yeah, the big B is the area of the base. So we're really taking 1/3 the area of the base times the height of the cone or of the pyramid. Okay? So don't forget that. Remember, the big B is the area of the base. So, you know, on this square pyramid right here, well, how do we find the area of a square? Well, it's just length times width, which is what they did. They did the 3 times the 3. Okay, which gave us 9, so that's our big B right there. Okay, then the height of this pyramid is 4. Okay, so that's how they get the 4 right there. And then they plug all those numbers back into the formula. 1/3 times the area of the base, which is 9, times the height of the pyramid, which is 3. So 1/3 times 9 is 3, times 4 gives us 12. Okay, that's how they get 12 for that. So it's very, very similar to finding the volume of, well, our cylinders and our rectangular prisms and our triangular prisms that we were doing last week, except in the front of that formula we stick a 1/3 in there. Okay, so let's take a look at the cone. The cone, again, is the same thing. It's the same formula, 1/3 big BH, and then right there it says or 1/3 pi r squared h. Well, why do they put that? Well, if you remember, to find the area of a triangle, it's pi times radius squared. Well, that right there is our formula for the area of a circle, which is the big B, times the height, times 1/3. So they take our radius, which is 2 to the second power, times 3.14, and then times our height, which is 3. What they did is they went ahead and left pi as pi right there, and then they multiplied it out, where we end up with 12.6 units squared, or whatever feet, or actually I guess it's cubed, feet cubed or meters cubed, or whatever the units are. But that's how we solve those. Okay, great. Let's take a look at our first example. Our first example, we have looks like a triangular pyramid here. Okay, no, triangular pyramid. So I have our formula right up here again, 1/3 area of the base times the height. So what we need to do is we need to first decide, well, what kind of base do we have here? So how am I going to find the area of it? Well, I'm looking at it right here. What is that base of that shape? Well, not the area. It's a triangle. It's a triangular base. So how do I find the area of a triangle? Base times height divided by 2. So my big B on this one is going to equal, let me see, our base times our height, which our height looks like 7, our base is 4. So we'd have like 4 times 7 divided by 2. Okay, and what is our height of our prism? Well, the height of the prism actually is kind of hard to tell in this picture. It's not a great picture, but the height is actually this line right here, which is 6. So we know that our height is 6. Now, once I've identified all the parts, I can plug them back into my big formula. Okay, so I know my volume is going to be 1/3, and I'll separate these with parentheses because I know that means multiply. Helps me keep it separate. 4 times 7 divided by 2 times our height, which is 6. Now, once I have that, now the work's easy. Okay, well, what's 4 times 7? Yeah, 28 divided by 2? 14. So I have 1/3 times, what do you say, 14? 14 times 6? No, is it, well, what's, I heard 84. What's 1/3 times 14? I don't know what that is, but I do know what 1/3 times 6 is. What's 1/3 times 6? 2. Yeah, because remember, all we're doing really is dividing by 3. So 14 divided by 3 doesn't come out even. But I know since we're multiplying, I can do it in any order that I want. So 6 divided by 3, that's 2. Well, what's 2 times 14? That's right. Okay, so we get 28. So our volume for this triangular prism right here is going to be 28 cubic centimeters, which I should write that right here so you guys get used to seeing that. Okay, not that hard. Again, as long as all we have to do is get our formula, plug our numbers into the formula, and then do the work. Okay, usually the work's not very hard. Usually getting all the numbers in the formula, that's the hard part, but that's not hard. Just take your time, plug them in, get your answer. All right, questions on that one? No? All right, then let's take a look at our last example, which, yes, is a cone. Okay, notice the formula is the same, but it's really just a little bit more involved than the previous one because the big B, what's my formula for the big B on this one? Like, how do I find? Yeah, pi r squared. That's right. So my volume is really going to be like 1/3 pi r squared h. Now, that's not that hard. I mean, it looks terrible, but it's not. I mean, all we're doing is plugging in numbers. All right, so let's start plugging in these numbers. The big B, we know, is pi r squared. Well, we know that that's going to be 3.14 times, what is my radius for this circle?
3.
Yeah, 3, so it'll be 3 to the 2nd power. Okay, and what is the h, the height?
10.
Yeah, 10. Okay, and then obviously it's 1/3. So let's go ahead and solve for my big B right here. What is 3.14 times 9? What was it? 28.26? Okay, so we have 28.26. That's my big B. So my volume, we're going to have 1/3 times 28.26 times our height, which is 10. 95 and a third? Okay. So, what do we say? When we multiplied 282, or 28.26 times 10, we got 282.6 divided by 3, or times 1/3 gives us what? 95 and a third? Okay. Or 95.3. That would also work. Or about 95.3, something like that. Okay. Is that good? We agree with that? I didn't check it. Is it right?
Yeah, I got 94.2.
Well, let's look. Let's look. I've heard 94.2. Well, let's double check. If we have our 282, or yeah, 282.6 divided by 3, that gives us 94.2. Let's see what we get when we multiply it times a third. Does that give us the same thing? Oh. Yeah. Okay. So yeah, this should be 94.2. I suspected by the looks on your faces that something wasn't right. But you guys got to say something. What do we say? 94.2? 94, yes. 94.2. Good. All right, questions on how we do any of those? Again, they're not that hard. Just take your formula, plug the numbers into it, and then do the work. Getting the numbers right in the formula, that's the hardest part, and that's not even that hard. Okay, so don't be overwhelmed by them. All right, then let's get to work.